So we have a function v of 3 variable, and v is given by f of r, where r is r squared equals to x squared plus y squared plus z squared. So using this, we have to find out the value of the second partial derivative of v with respect to x, y, and z, and the sum. So let's begin. So here we have v equals to f of r. Now we'll take the partial derivative of function v with respect to x. That means we have to take partial with respect to x of our function f of r. So that means here we have partial with respect to r of f of r times partial of r with respect to x. So this is the chain rule. So that means we have f prime r. So f prime r is derivative, partial derivative of f of r with respect to r times partial of r with respect to x. Now we have been provided that x squared is equals to x squared plus y squared plus z squared. So if we take the partial derivative on both sides with respect to x, we have r squared, so that will be equals to partial with respect to x of x squared. We don't have to worry about the other two terms because partial of y squared with respect to x and partial of z squared with respect to x will be 0, where y and z will be treated as a constant. That means we have 2r times partial of r with respect to x. That will be equals to 2x, such that we have partial of r with respect to x equals to x over r. Now in similar fashion, if we take the partial derivative of r with respect to y, then we will get y over r, and partial of r with respect to z, so that will be equals to z over r. We'll be using this value later on, but first let's use partial of r with respect to x, and we'll replace this with x over r. So this is the partial derivative of our function v with respect to x. Now what we'll do, take the second partial derivative with respect to x. So that means we will take partial derivative with respect to x of partial of v with respect to x, which will be equals to partial with respect to x of f prime r multiplied to x divided by r. So here we'll have to use the quotient rule, and this will be, so we have second partial derivative of v with respect to x. So let's take the quotient rule. We have in the denominator r squared. In the numerator we have r multiplied to partial with respect to x of the numerator, which is f prime of r times x, minus we have f prime of r multiplied to x. So this will be multiplied to partial with respect to x of r. Fine. So this will be r times, so here we'll have to apply the product rule. So let's expand this. So we'll have partial with respect to x of f prime of r, a whole multiplied to x, plus f prime of r times partial of x with respect to x, minus we have f prime r times x multiplied to, so partial of r with respect to it, we can replace it with x over r. So this whole thing is divided by r squared. Let's further simplify. We will have r times, so here partial with respect to x of f prime r, so this will be represented as partial with respect to r of f prime of r multiplied to partial of r with respect to x, and we also have an x multiplied to it, plus we have partial with respect to or partial of x with respect to s, so that's simply 1, which gives us f prime of r, minus x squared divided by r, so this will be multiplied to f prime of r whole divided by r squared. Fine. That means we now have r multiplied to, so partial of f prime of r with respect to r, so that will be f double prime r multiplied to partial of r with respect to x, so we can replace it with x divided by r multiplied to x, so we have x squared times the x squared divided by r, plus f prime of r minus x squared divided by r times f prime of r whole divided by r squared. Now we will multiply r to each of the two terms within the parentheses. So that means we now have r. So here r will get multiplied to this particular r, so they will get cancelled out. That leaves us with x squared multiplied to f double prime r plus r times f prime r minus x squared divided by r times f prime r whole divided by r squared. Now we'll divide each of the terms in the numerator with r squared. We'll get x squared divided by r squared times f double prime r plus we have r over r squared, so that will give us 1 over r times f prime of r minus we have x squared over r divided by r squared, so that will be x squared divided by r cube f prime of r. So this is the value of the second partial derivative of v with respect to x. We'll label this as number 1. Now using this similar approach, we can also find out the value of second partial derivative of v with respect to y as well. So this will be equals to, so in place of x we'll have y squared, so we'll have y squared over r squared times f double prime of r plus 1 over r times f prime of r minus we have x squared over r cubed, so in place of x squared we have y squared, so that gives us y squared over r cubed multiplied to f prime of r. So this will be number 2. And we can also find out the second partial derivative of v with respect to z, so this will become z squared divided by r squared times f double prime r plus 1 over r times f prime of r minus z squared divided by r cubed times f prime of r. So this will be number 3. Now what we can do, we can add 1, 2 and 3, which will give us the second partial derivative of v with respect to x plus second partial derivative of y, v with respect to y plus the second partial derivative of v with respect to z. So that will be equals to, so we can add these 3 terms. So here we have 1 over r squared times f double prime r, so this will be common and this will get multiplied to x squared plus y squared plus z squared plus, so these 3 terms will get add, they are same. So we have 3 over r multiplied to f prime r minus we have x squared plus y squared plus z squared divided by r cubed whole multiplied to f prime r. Right. Now what we can do, we can replace x squared plus y squared plus z squared, this value, with r squared. So we can replace this with r squared as well. Now we will get 1 over r squared times f double prime r multiplied to r squared plus 3 over r times f prime of r minus r squared divided by r times f prime of r. So here we have r squared and r squared cancelling out. This is r cubed, so we have r squared and 1 r squared cancelling out, which leaves us with f double prime of r plus 3 over r times f prime of r minus 1 over r times f prime of r. So we'll combine these 2 terms and this is going to give us the final value. So we have the second partial derivative of v with respect to x plus the second partial derivative of v with respect to y plus the second partial derivative of v with respect to z. So that will be equals to f double prime of r plus 2 over r times f prime of r. So this is the final value.